Hello everybody and welcome to another episode of Flux for professional creatives. Today we'll be talking about Flux LoRAs and more importantly about how to train them, the easiest and cheapest ways to train them, and some experimental ways to train LoRAs targeting either single layers and or LoRA training with single images. Now, up until Flux, I was not an expert in LoRA training by any stretch of the definition. LoRA training is something that you have to spend a lot of time in order to gain some sort of finesse. So whenever I needed LoRAs for work, I always had some people that I could rely on that could take care of that part of the work. But with my new jobs and with Flux being able to be trained on in a fairly more straightforward way, I feel a bit more confident about how to show you how I train my own LoRAs. So let's start from the basics. How do I train LoRAs? There's so many different ways to train LoRAs either locally or on the cloud. And there's so many different front ends and software you can use in order to train them. Personally, I am not a fan of a lot of the graphic user interfaces that I've found up till now. And I guess that has something to do with my not wanting to train LoRAs up till now. I find them all too complex when I can just use terminal commands and config files. And because of that, I decided to work on LoRAs on RunPod, which is a cloud-based platform. And as for software, I decided to land on AI-Toolkit, which is pretty straightforward in its approach, but let's not jump ahead. But regardless of whether you want to train LoRAs on the cloud or locally, the process involving AI-Toolkit is basically the same. I'm going to guide you first through setting up a cloud GPU instance with RunPod and then setting up AI-Toolkit before actually delving into the configs for the LoRAs. After that, we're going to take a look at two different kind of very experimental LoRAs, which is one image LoRAs and single layer targeting LoRAs. So first of all, on RunPod, you can rent so-called pods, which are basically bundles of GPU and storage space. And you can see here that I have a few pods already set up. I have here a 4090 set up with AI-Toolkit, an A40 with AI-Toolkit as well, a ComfUI environment for production, as well as an H100 set up with AI-Toolkit. All of these instances are paid as you go, and depending on your hardware of choice, they can be either very cheap or kind of costly, like this H100 here that costs around $4 an hour. But regardless of how much you actually spend on hardware, if we take a look at the homepage, I work in actual production and I don't spend a lot, even if I work basically every day on cloud GPUs. My rolling average, for example, is around $6 a day, which is not much, honestly. Moreover, if you think that I spend around 10 hours a day on these instances. But let's take a look at how you can actually deploy your own pod. Well, first of all, you want to click on deploy here, and you're presented with a ton of different hardware choices. Now, if you want to spend a ton of money and you're really in a rush, so every seconds per iteration count, you want to go with hardware such as the H100. But on normal production days, I choose either a 4090 or an A40, which are slower cards, but they've got everything that I need in terms of VRAM and speed, even if they're not the fastest. One of, if not the cheapest way to train LoRAs for Flux is by using the A40, which in this case costs around 40 cents an hour. So you want to click on it, and then you've got a few things to choose from. Let's start by the template. While you can find some templates aimed specifically at things you want to do, like in this case, if I click on change template and look for AI-Toolkit, I can find a Docker container that should be giving me exactly what I need. But since most of the things that I do need to be on specific versions of GitHub repositories, dependencies, modules, whatever, I would rather go with a base template, like the RunPod PyTorch 2.2, and then install anything that I need on top of that. So I'm gonna leave the RunPod PyTorch 2.2. I am not gonna care about the GPU count, mostly because Flux training cannot work on multiple GPUs. I am going to select on demand because I want to be able to start and stop the pod wherever I want to, and I'm going to click on edit template. Now this is very important. You want to make sure that you have enough space on your disks. Flux is a very big model, so for good measure I'm going to go with 80 and 80 gigabytes of container and volume disk. Not necessarily because these are the correct values, but because it gives me some headroom, and honestly, disk space is quite cheap on RunPod. Next, I will set this as overrides, and I will click here on deploy on command. My pod is being built as we speak, and I will be shortly redirected to my pods. Now here we will see the RunPod PyTorch 2.2 that is up and running. Now, this pod is not doing anything right now. It's not doing any computation, and it's not even set up for actual LoRa training. In order to do that, we want to do two things. The first thing we want to do is click on Connect and select Connect to Jupyter Lab. A new tab will pop up and we will be transported inside of a user interface. Now, for those of you who have never used Jupyter, think of this as basically a hybrid of a file explorer and a terminal. I'm sure there's a ton of engineers out there swearing at me saying this, but hey, I'm not an engineer, so I can get away with these things. The next thing you want to do is go over to the GitHub page for AI-Toolkit. You will find the link in the description below, and more specifically, you want to look for the setup for RunPod. Regardless of whether you're using RunPod or a local machine, it's going to be basically the same, because the motions that we're going through will work either on RunPod inside of the workspace folder or on your local machine inside of your directory of choice. The next thing you want to do is copy the code here. You don't need to copy it line by line, you can just copy it whole. Go back to your Jupyter Lab tab and click on Terminal. Now you have to be in the workspace folder, but you're most probably going to be because you just opened it. Now you're going to click on Terminal and a terminal-like interface will show up. What you want to do is right-click, paste. If you have a pop-up asking you whether or not you can actually copy and paste on this tab, you're gonna click on allow. All the commands are gonna pop in here and just have to click on enter, and all these lines of commands will execute one after the other. Now it's gonna take a while depending on your hardware. For example, we are working with an A40, so it's gonna take a couple of minutes, but if you were working on an H100 for example, it would be much faster. But hey, we are here for cheap, not for actual performance, and to be fair, there's some diminishing returns if you're employing some top-of-the-line hardware. The way I usually work is test things out on top-of-the-line hardware in order to be quick and kind of loose with the parameters I use, and when I eventually find the parameters that I like, I switch over to cheaper hardware for mass training. In case you are not doing this on RunPod and you're doing it on your local machine, what you want to do is, instead of going to your Jupyter Lab tab, you want to create a folder such as this one named LoRa Training, open it in Terminal, and paste the commands. A warning will pop up that says that it contains multiple lines, and if you paste this all, it will result in execution of all the commands. Do I wish to continue? Well, yes, because I know what they do. And there it goes, and it does the same thing all over again, but in your local machine instead of on RunPod. From here on out, I will keep talking about how to do things on RunPod, but it's basically the same thing if you do them on your local machine. Now, this took a while on A40, but it's still like cents on the dollar. Now we gotta do two things. I'm gonna do an apparently useless thing first, because if you're kind of stupid like me, you're gonna run into it and you're not going to know where you went wrong. So the first thing that I'm actually gonna do is stop the pod, like I am done with it for today, and I would just like to stop it and not pay anymore. It's gonna tell me that I will be charged 2 cents a dollar per hour because of volume storage. I'm gonna stop it, and then I am gonna start it again. I'm gonna select the GPUs that I wanna use, in this case one A40, and start it. Once again, I'm gonna click on connect, and then connect to Jupyter Lab. And what I want to do is double click on the folder AI-Toolkit over here and on Terminal, and type the command pip install -r requirements.txt. And that's because one thing about not using templates for this kind of pods is that on startup, they will lose all the requirements that have been installed and are not specified in the startup sequence. And this doesn't take a lot of time like the first actual install, because most of it is already there. But if you stopped your pod and then started again and tried to run a LoRa training without installing the requirements first, you will end up getting errors upon errors of missing modules. And it's because of this. In the meantime, I've moved myself from under here to over there because I realized that otherwise I will cover the terminal commands that I'm typing. So now that we are almost ready, we want to do one more thing. Flux Dev, which is the model that we are going to train on, is a gated model on Huggingface. That means that in order to download it, you have to agree to terms and conditions. And on Huggingface, that's kinda easy. You just had to click on a pop-up here and then you'll be ready to go. It will be tied to your account. But if you want to download it from a command line interface, you would have to find a way to tell Huggingface that you have the necessary requirements to download that gated model. So how do you do that? Well, good thing is that there's a way to use tokens. In this case, we want to create a read token. And how do we do that? We go over to the preferences and settings for our profile, click on access tokens over here, and then we create a new token. Again, we want to create a read token, so we're going to select read. I'm going to give it a name, like in this case, let's say YouTube. I'm going to create the token. It's going to be displayed here one time only, and spoiler alert, you won't be actually able to use my own token because I'm going to delete it after this video is recorded, so don't try that. I'm going to copy it. I'm going to go back to the Jupyter Lab tab and I'm going to type here Huggingface-CLI login, press enter. I'm going to paste my token. It's not going to be visible. I'm going to press enter. I'm going to be asked if I want to use this token as a Git credential. Regardless of whether or not you press Y or N, you're probably not going to make a difference because Git credentials are not initiated. But let's say I press Y and enter, and then the login will be successful. This way I will be able to download and use the Flux Dev models. So now that you have the actual software and credentials to do all the training, what you now need is a dataset and a config file. I won't delve too much into how to construct a dataset, mostly because all the dataset compositing that I do is fairly narrow and aimed at one thing only, which is fashion and product photography. So I am not the best at talking about it, but what you would essentially do is something like this, creating a collection of images, in this case that's me, to use as a reference for LoRa training. I renamed all of my images in a fairly straightforward naming convention: 1.jpg, 2.jpg, 3.jpg, 4.jpg, and what I want to do is go over to workspace, create a new folder by clicking on this icon over here, name it something I can remember, like NDR_BNI. That's basically 3 letters from my name and surname, Andrea Baioni. I'm gonna double click on the folder and then I'm gonna drag and drop all of the images inside of it. And this is where Jupyter is a lot easier than just a straight up terminal, since you can interact with it rather than try to do everything by command line. The next thing we want to do, if you haven't done so already inside of your own PC, is create text files for each of these images. So I'm going to click on plus here and create text file. Now there's so many different ways and so many different school of thoughts about how to tag a dataset. But this is all part of dataset, and as I said, I'm not going to delve too much into it. Suffice to say that what I like doing is not using tags at all except for a single keyword. I know there's people out there who love using a ton of different tags and keywords and whatever. I know that some people like using natural language description, automated tagging with Florence 2, or joy caption or whatever. I personally like just using one single keyword. So in my case, that's going to be NDR_BNI. I'm going to save this text file as 1.txt, and I'm going to duplicate the 1.txt 3 times, since basically the captioning is going to be the same for every single image. The only thing that I have to do is rename each file to 2.txt, 3.txt, and 4.txt. That's because each image name must have a corresponding same image name.txt file. Now, the last thing that we want to do is create a config file. In order to do that, we want to go over to AI-Toolkit folder, config, and we can either go inside of examples, or you can find an example config file in the description below. For these ones, I am going over to examples, double click on train LoRa Flux 24GB.yaml, and I'm going to have the config file over here. And before changing anything else, I am going to save it as, and I'm going to change the directory path by getting rid of examples, so just AI-Toolkit config, and rename it to ndr_bni_test.yaml and save it. I want to be sure that I have the actual config file in the right folder, so I'm going to go back to the config folder, and there it is. Now, don't be scared of all these configurations. What you actually need to do here is not a lot. The first thing you want to change here is on line 5, name, and that's for me is going to be ndr_bni_test_1. Then we want to go over to lines 18 and 19. That's linear and linear alpha. If you're used to other UIs, this is usually called rank. I'm not gonna go much into technical explanations here, but suffice to say that the lower the rank and the alphas are, the longer it will take to train the model, the smaller the LoRa will be in terms of file size, and the harder it will be to overcook it. So for now, let's keep it at 16:16, or if you want to be adventurous, change it to 32:32. From what I've read, you almost always want to keep linear and alpha at the same kind of values, but there's some people who are testing with linear being double than alpha. Linear or rank takes care of larger concepts usually, whereas the alpha takes care of smaller details. The last thing you want to know that this is in double increments, so 16, 32, 64, 128. The next thing we want to change is the save array, and the number here is referred to the steps, after which it will save the model. The model will not have finished training, but it will be a snapshot of the model at that moment in time. I personally like saving every 50 steps. That's because I like having everything under control and in the early stages knowing how things change, even with a smaller increment in steps, but I can definitely see reason to just go every 200, 500, whatever. Then you want to set how many epochs you actually want to keep around. In my case, I want to keep around all of them because I don't know what's going to happen. So what I usually do is just divide the total number of steps per the save every step count, and that's the max steps to keep. In my case, let's say I want to go up to 600 steps, so that's going to be 600 divided by 50, and that's going to be 12. Then we want to specify the folder path to our dataset. In order to get that, we want to go back to our folder for our dataset, right click on it and copy as path. Now we're going to go over here between these two quotes and Ctrl V, the path to our dataset. Now in my case on line 39, resolution, I still have to settle on a resolution that I like. I just know that I don't want to train on different resolutions. So for this one, I'm just going to train on 512. So I'm going to select everything else and delete it. Then we want to choose the training parameters. Batch size, I'm going to leave it at 1 for now, but I've seen people getting away with 2 or 4. And steps, as I said, I want to go to 600. Why so low, you might ask? Well, in my testings, you can get good results even at 200, 300, 400 steps. So for starters, I'm going to start with just 600 steps. And then if I deem it necessary, I will resume training starting from the save state at 600. The next things we're going to do is take a look at the learning rate. For now, I'm going to keep it at 1e at the power of -4. That basically equals 0.0001. But I've seen people testing on other values like 4e at the power of -3, but for now let's keep the learning rate quite low. Then on line 72 I want to set the sample every number of steps the same as the save every number of steps value, so that every time it saves a partial training I get images out of it to test it. So in my case I'm going to set it to 50, and the last thing we want to do is set 1 or more prompts for testing. In this case, every 50 steps an image will be generated based on these prompts. So in my case I want to go with a photo of ndr_bni in Central Park, for example. Something easy, but not too easy, that will give me an understanding of whether or not the model is actually training well. And of course, ndr_bni is the trigger word that I chose and placed in our text files in the dataset folder. After all of that is done, I can just save the file, go back to my terminal page and start training. In order to start training, you want to write down Python run.py config / and then the name for your training configuration. So in this case, that's going to be ndr_bni. And then if I don't want to go on writing stuff, I can just click on tab and it will autocomplete. Then I'm going to go click enter and it will start the job. The first time I'm going to use this training on a new pod, it's gonna download all the models that are necessary. But good thing is that regardless of the hardware that we're using on RunPod, the connection is quite phenomenal. And after it is done downloading everything, it will start training. We can see here that it cached some latents to the dataset folder. You don't have to worry about that. And it's now generating the baseline images. If we go over to the AI-Toolkit folder, and the output folder, we will see that the ndr_bni_test_1 folder has been created. If we double click on that, we will see a config.yaml file, and that's gonna hold all of the settings that we used for this particular training, and that's useful for remembering what actually happened. And when the first generated image will be done generating, we will see a samples folder with our baseline image. Of course, ndr_bni is not a word. So the first image it created, it's just a central park image. While we were talking, the training is going on and on and on quite fast actually, even on an A40. It's going over at 2.5 seconds per iteration. And on a 600 steps training, that's not a lot of time. Actually, the most time you're going to spend is on generating images, because on an A40, it's going to take around 35-40 seconds to generate one single image. So the more images you actually generate, the longer it will take training. But the training per se, it's just going to take around 20 minutes, at least for 600 steps. And after a while, we can see how this woman over here morphs into more and more my own face. Now, the hair is not quite perfect yet, so that might mean that it needs more training. More so because later stages like the 600 steps show regression, so it looks like it's not properly perfectly baked yet. In order to continue training, what we can do is just go back to our configs. So in the config folder, looking for the config file, we are just going to locate the steps number on the line 42 in my case, and we're going to add some more steps, let's say up to 800. And now in the terminal, we're just going to run again the same job, and since we are targeting the same dataset and the same output folder, it will start again from the latest save state, which is step 600. And there we go. We can see that we are getting there. This is around step 750. I much prefer this method of incremental training because I can control each and every step of the way. Whereas with setting like 2,000 steps, 3,000 steps, I'd either have to kill the process or just wait it out until the end and then maybe pick an intermediate step, and all the remaining time has been basically lost. But that's just me. Now, can we actually train on just one image? Yes, this is something that was very hard with SDXL or SD 1.5, and it didn't give quite good results, but it's definitely possible to train concepts and simple objects and subjects on just one image. In order to do that, let's duplicate my dataset. In order to do that, let's create a new folder called ndrbni_single. And let's upload just one image. Let's create a text file, and let's write ndrbni, which is my default trigger word. Let's save it as 1.txt, and let's create a new config file. For example, let's duplicate ndrbni.yaml and rename it to ndrbni_single. Double click on it, and let's do a quick changing of the name for the output folder to single_1. And what we want to do is really force the training, because we only have one image. So in this case, we're going to go with rank 64, that's linear 64, and alpha 64. I'm going to save every 80 steps because I don't expect this to be solvable in a low number of steps. I'm going to increase the trained batch size to 2, and I'm going to increase the learning rate to, let's say, 4e times -4. I'm going to sample every 80 steps, same as the save states, and I'm going to save it. Then in the terminal, I'm going to go once again to python run.py config ndr_bni_single.yaml and hit run. Now in the output folder, we will see how this will play out, but this is still very experimental. Some people are getting very good results with it in text-to-image generations. I am getting good results as well. I haven't quite nailed the parameters yet. My main issue with single image LoRAs is that they perform very well in text-to-image pipelines, not so well in in-painting pipelines, but I'm sure we'll get there eventually. And there we go, we are starting to see some convergence from as low as 160 steps. Now the air, of course, is not great, but the face, well, come on. That's me. So yeah, one image LoRa is definitely possible with Flux. Also, Flux is very difficult to overtrain, so you can just keep this running a lot and it will eventually work. This guy at 240 steps has definitely better hair, but hey, why am I looking so gloomy? One thing to note is that by forcing faster learning rates, the images start to look a bit overcooked. So you want to really try to find the parameters that allow single image trainings while still getting good results out of the images that are generated. The last thing that I would like to talk to you about today is training on specific layers or even single layer blocks. What are layers or blocks? Think of a checkpoint as a lasagna of layers, each taking care of different things in the diffusion process. In order to generate an image, you would need all the layers. But in order to influence what the model does, you don't need to train all of the layers. You can just try to train some of the layers. Now, it's very hard from a layman perspective to understand what each layer does. But let's just say that earlier layers are more important in terms of general concepts in the generation process, and later layers take care of smaller things, smaller details, smaller concepts. This specific layer training became known a couple days ago, mostly because of the contribution by Yakben on Reddit, where they showcased this LoRa of Sandog Kliegen trained on only two specific layers. That's single transformer block 7 and single transformer block 20. And the results are pretty amazing. What this does in terms of LoRa training is resulting in faster training processes and smaller LoRa sizes. This is especially good for scaling, for example, because 64 or 128 rank LoRas trained on just 1 or 2 layers end up with a file size that is less than 10 megabytes, for example. So you can see how if you had to train lots and lots of different LoRas at such high ranks, which usually weigh around 600 megabytes, this would be pretty great. In order to do that inside of AI-Toolkit, what you'd need to know is once again to go to the config folder, create a new YAML file. Let's say we want to duplicate the ndrbni YAML and rename it to ndrbni_target. Double click on it, and then right here on line 19, you want to add a couple of lines of code. And it's these lines: dropout 0.1, network, keywords, only if contains, and then the blocks you want to train on. Usually you would want to train the first blocks between 6 and 10, and then the later layers around block 20. Once you've added these lines of code, the testing for now has been done on rank 128 and alpha 128. And it appears, but once again, this is all very experimental and very new, that the learning rate must be higher than the usual learning rates. And I'm personally testing with 4e times -3. And for now, I'm going to keep batch size 1, but I've seen people try batch size 2 and 4. Then I am going to change the name to ndrbni target 1, save the file, and then launch it with python run.py config /ndr_bni_target.yaml. Now I am running this job with the 4 images dataset, not the one single image dataset. Another thing that you have to keep in mind is that this thing is so experimental and so new that you'd probably need to update the AI-Toolkit folder by typing git pull and pressing enter in the AI-Toolkit directory. Otherwise, like in my case, you would get an error running job list index out of range. So if that happens to you, just update the repo. But you can see just from very early results, this is step 0, the baseline, and this is step 50, that we are starting to get very quick results. Now, these are very clearly overbaked already at step 50, so we might need to fix the parameters. But even on step 100, we are starting to get even better results. The training is much faster now. I swapped swapped to an H100 instead of the A40, but I'm getting 2.5 iterations per second instead of the usual 1.5 seconds per iteration. And the file sizes for the LoRa safe tensors are much smaller, around 10 megabytes at rank 128, but we can see some very fast degrading the further that the training goes on. Or at least I hope so. I hope I'm not like that guy. So beware of that. You might want to save every 10, 20, 30 steps and see where it takes you. So all in all, that's how I train LoRa's with Flux. Again, I'm definitely not an expert on LoRa training, but this is what has been working for me. I hope you had some fun and learned something new. I want to thank everybody who's supporting me on Ko-fi. If you want to check out RunPod or the config files that I am using, you can find them in the description below. You won't be able to find my own dataset, because let's face it, you don't want to train on my face. My name is Andrea Baioni. You can find me on Instagram @ReasonableBushy or on the web at andreabaioni.com. And same as always, I will be seeing you next week.